Good morning, or at least for me. I don't know when you're doing this, but welcome. We are doing logarithms today. This is a big day. We're going to cover a lot of different things. At first glance, it might seem a lot different, but I think you'll get the hang of it. So today's lesson really ties back more into like 6.2. When we did 6.2, we dealt with like how logs and exponential graphs are inverses of each other. That's going to be the main theme today. Log problems look scary, but if you can follow what we're doing today, they're not too bad. If I were to say which section in this whole chapter is the most important, it's this one. This is the one that's going to have a majority of the information that you need to know to be successful in here. All right. So with that in mind, let's get to work. I brought this one up earlier, but it says if you want to find the answer to 2 to some power is equal to 7. Again, I like to think of this as like the theme of the chapter. 2 to what power gets me 7? This is a main concept. Okay, that looks so easy to solve, but right now we do not have the math skills to solve it. Okay, 2 to what power gets me 7? Well, 2 cubed gets me 8, so I know that x has to be less than 8, but 2 squared only gets me 4, so it's got to be bigger than 2. So it's somewhere between 2 and 3. Right now we don't know how to solve it, and the next two chapters now we'll be able, or next two sections we'll be able to solve that. All right, so a reminder, log base 2 of 8 is equal to x is the same thing as 2 to the x power is equal to 8. Remember, that's just like 5 is equal to 2 plus 3, or 5 minus 2 equals 3. Two different ways of writing it, but they're the same number family. All right, so log base 2 of 8 is equal to x. Remember, oh, I got a log base 2. What is the opposite of log base 2? It's 2 to a power. And so if I raise both sides as 2 to a power, I get 8 is equal to 2 to the x, which is the same thing as that. If you write it in this form, now it doesn't look as scary. In this form, I'm not great at logs, but in this form, 2 to some power is equal to 8. 2 times 2 times 2, oh, that is 8. Or in other words, 2 to the third is 8. So my x is 3. That is the thing we're trying to solve today. So keep that in mind as we go through it. All right, so we're trying to evaluate each. So the key to evaluating a logarithm is don't let it stay a logarithm. When we see ugly stuff like this, the first thing we're going to do is get rid of the logarithm. Opposite of log base 2 is 2 to a power. So I just get 8 is equal to 2 to the x. We just figured that out. X is equal to 3. Letter B, log base 3 of 1/27 is equal to x. Notice that a lot of times we would get a problem like this. They'll say evaluate that, log base 3 of 127. If you just see that and it's not equal to something, just make it equal to something, and then we can solve it from there. All right, want to get rid of log base 3, so 3 to a power. That's going to cancel. 1/27 is equal to 3 to some power. 3 to some power. Okay, well, think back to our last section. I need to rewrite this as 3 to some power. Could I rewrite 1/27 as 3 to a power? Well, it's a fraction, so I know it's going to be negative. That's a negative sign, I swear. And then 3 times 3 times 3, that is 27. So in other words, 3 to the negative third is the same thing as 1/27. Well, if I write it like that, now I've got a base of 3 on both sides. Those can cancel. Negative 3 is equal to x. Boom, I solved it. Let's keep going. Letter C, again, we got log base 9 of 1. Well, I don't want to leave it like this. I want to rewrite it as an exponential, so I'm going to make it equal to x. I'm going to raise both sides to a base of 9. 1 is equal to 9 to the x power. 9 to what power is going to get you 1? That's a math fact you need to know. Anything to the 0 power gets me 1, so that's what C is there. And letter D, I'm going to make it equal to x. To get rid of log base 7, I'm going to raise both sides to a base of 7. This cancels. 7 to the x. I need to rewrite 1/49 as 7 to some power if I can. And I can. 7 to what power gets me 1/49? Well, negative. And 2, because 7 squared gets me 49. Well, if I write it that way, 7's cancel. X is negative 2. So that's evaluating a logarithm. When it just says evaluate, basically it just means find out what it's equal to. Okay, and that's what we were trying to figure out there. They could look like that. They could also look a little fancier. Let's look down below. So some of these look tough. Some of them are pretty easy. Don't let them be scary to you. So log base 5 of 2x plus 1 is equal to log base 5 of 3. Well, this problem right here is the same thing as 5 to 2x plus 1 is equal to 5 cubed. If I gave you that problem, what would you do? Well, you would cancel out the bases of 5 on both sides because they're equal. Same thing's true here. Log base 5 and log base 5. If they're both log base 5, and it has to be written just once, okay? It's log base 5 of something is equal to log base 5 of something. Those two things can cancel. And now you're just left with this problem right here. 2x plus 1 is equal to 3. Well, if I've got 2x plus 1 is equal to 3, that's an easy solve. Minus 1. Divide by 2. Done. If I plugged in 1 here, I would get log base 5 of 3 is equal to log base 5 of 3. Yeah, that's a true statement. Number 2, I don't know why I put this problem in the notes 47 times. We're going to raise both sides log base 2. 2 to what power gets me 8? It's 3. Next one, log base 2 of 3x is equal to log base 2 of 6. Again, I've got log base 2 on both sides. I don't need those anymore. I just get 3x is equal to 6, so x is 2. That's pretty easy. Hopefully you're seeing what's going on with that. Number 4, log base 2 of that is equal to 5. The first thing I want to do is get rid of log base 2. How do I do that? 2 to a power, 2 to a power. That's going to cancel. X plus 3 is equal to 2 to the 5th. Well, 2 to the 5th is just understanding this. 2 to the 5th is 2 times 2 times 2 times 2 times 2. These two get you 4. Those two get you 4 times 2. 4 times 4 is 16 times 2 is 32. You could just know that, but I'm just showing you. That's not as scary as it seems. 2 to the 5th is 32. Minus 3. X is 29. Number 5, log base 8. Don't like log base 8. How do we get rid of it? 8 to a power, 8 to a power. Those two things would cancel. 4x is equal to 8 squared. 8 squared is 64. Divide by 4. Divide by 4. X is 16. If you don't know that one, use your calculator. I'm good at numbers, so I know that one without slowing down. Log base 3 of 1 over 81 is equal to x. Get rid of log base 3. 3 to a power, 3 to a power. Cancel. 1 over 81 is equal to 3 to the x. If I can solve it right now, I need to rewrite 1 over 81 as 3 to a power. It's going to be negative, and then 3 to what power gets me 81? 3 to the 4th. That might not be one you're perfect at, but keep getting better with powers. It'll help you understand. So x is negative 4 because those two things would cancel. I'm doing a lot of examples, but I just want you to see them and get comfortable with them. Number 7, raise both sides to a base of 5. Boom. X is equal to 5 cubed with 125. All right, number 8. Oh no, log base A. That's so weird. Oh, but this one is log base A as well. So if they're both log base A, I don't really care what log base A is. It's just going to be x squared is equal to 49. To get rid of the square, we are going to square root, and square root x is equal to 7 and negative 7. Because if I take a square root, it could be positive or negative. Now, with that being said, something that you need to remember about logs. Okay, so we just did this a couple chapters or a couple sections ago. But if I wanted to do log, oh no, we're okay here. I just want you to make sure we see this. So I'll just show it to you. Log base A of negative 7 squared. Negative 7 squared is going to be okay here. But remember what a log graph looks like. It looks like that. The x values that I can use here always need to be on the right side of the x-axis. Or in other words, my argument can never be negative. What we're plugging in right here cannot get me a negative number because it's always to the right of it. In this case, when I plug in negative 7 and I square it, it is going to get me 49. But when we choose a number, it needs to be on the right side of that argument. Just something to be, or right side of 0. So just something to be aware of, and we'll get to more examples of that later on. Log base 2 of 6x is equal to 3. To get rid of log base 2, just kidding. I'm going to raise both sides to be a base of 2. Divide by 6, divide by 6, x equals 4/3. I can kind of go through those pretty quickly, just a matter of going through them. All right, so we solved, again, the key to solving is just getting rid of log bases, and we know how to get rid of log bases at this point. Remember, logarithms are exponents. They're inverse of exponents, but they work the same way. All right, so for example, if I gave you x squared times x cubed, that's something you did in Algebra 1 all the time. X squared times x cubed. They both have the same base, so I can put them together. What do I do with the 2 and the 3 here? Well, I'm going to add those two exponents. If I am multiplying two bases that are the same, I add the exponents. Okay, same thing here. If I had x to the 6th over x squared. Well, if I were going to divide x to the 6th and x squared, remember what you do with that. You cancel out two of them, or in other words, this would be x to the 4th. So when you're dividing two things with the same base, two exponents with the same base, you really subtract the two exponents. And then the last one that you need to know is this one, x squared cubed. I'm going to switch that just to make it a little bit easier. X cubed squared, same difference. Okay, what does this mean? Well, that means x cubed times x cubed, because squared means there's two of them. And so what is that going to get you? It's x to the 6th. So if you are raising something to a power, it's the same thing as just multiplying them together. All right, so this is properties of exponents. We're just going to apply them to logs. So just be aware of what's going on here. All right, so anytime in algebra and we see many logs on one side, so like this one, I got a log base 3, a log base 3, a log base 3. When you have more than one log on the same side, we are going to condense it. We're going to push it into one. All right, so as I look at letter A here, I see log base 3, log base 3, log base 3. When I see more than one, I'm going to rewrite it as a single logarithm. These are logarithms, and it's got a plus sign. When we see two logs being added, it is like we are really multiplying them, because when we multiply things together, we add their exponents. Okay, so here we're adding them and we're combining them into one. We are going to multiply 4 and x together. So this is going to become 4x. And then we have a minus sign. Well, what is the same as subtraction? Subtraction is the same thing as dividing. And so if it's a minus sign, basically the minus sign is going to tell me whatever argument comes after it. And that, I haven't brought that up yet, but the part after the log base is called the argument. That y is going to go on bottom. So because these two are added, I multiply them. Because this one is minus, it goes on bottom. All right. We condensed it into a single logarithm. So let's look at the next one. Log base 3, log base 3. Next one, it's 2 log base 3x. Well, this one I got a 2. It's being multiplied. Well, what is the same as two things being multiplied? Being raised to a power. So what I'm going to do with this 2 is this 2 is going to become my power here. So if I've got a number in front, it is the same thing as writing it as x squared. Same thing here. I've got this 4. It's in front. It's being multiplied. It's the same thing as y to the 4th power. And they're being added, which in the same case with logs is multiplying them together. A little bit strange to do this. This is called condensing the logarithm. But again, it's following these rules. So when you're like, oh yeah, this is really weird, we've done it before. One more here. Log base 3. We got it written 3 times. We're going to condense it into just one. Oh, this 3 is really the exponent. Oh, that 2 is really the exponent. So I get 2 cubed. Well, 2 cubed, I'm just going to write 2 cubed. It's 8. Plus sign. So since it's a plus sign, it means it's being multiplied. That 2 is going to go as an exponent. Oh, it's minus. That means I'm dividing by y. That is condensing logarithms. It's weird. You'll get the hang of it. Don't let it be too crazy. All right, so let's looking at some examples of this. Log base u. Oh, it's a plus sign, so it's going to be multiplied. This 6 is going to become an exponent. So I'm looking for v to the 6th and w cubed. They're all being added, so they're all being multiplied. It's b. U, v to the 6th, w cubed. Same thing on the next one. 36 is going to become an exponent. 36 is going to become an exponent. Negative 6, or the 6 is going to become an exponent. Oh, hey, that's negative. That means it's going to go on bottom. So I know I want y to the 6th on bottom. Well, that one doesn't have y to the 6th on bottom. That one doesn't have y to the 6th on bottom. The only one that's negative is the y, so that's the only one that's going to be on bottom. I want C. Now, why do we need to do this condensing? Because it's going to help us solve. All right, so looking at number 1, I want to condense and solve. We have to condense first. So if you look at this one, you see log base 2, log base 2, log base 2. Some students will do that. Do not do that. You can't do that. Okay, we have to condense it first in order to solve this thing. So that 2 is going to become an exponent. So that's x squared. It's minus log base 2 of 5. So if I'm minusing that, I'm going to throw that 5 on bottom. And that's going to be all equal to log base 2 on 5 on this side. So we're going to condense it first. All right, so we condensed it first. And why did we condense it? Because if we condense it, now this log base 2 and this log base 2 can cancel. Now I'm just given an easy problem. X squared over 5 is equal to 5. Let's solve it. So to get rid of the 5, I'm going to multiply by 5. To get rid of this 5, I'm going to multiply by 5. Boom. That's going to go away. X squared is 25. Well, if x squared is 25, we are going to square root. Square root. X is equal to plus or minus 5. All right. We just need to double check that if I plugged in plus or minus 5, it would always give me a positive number here. It would, because if I plugged in a negative 5, it would be negative 5 squared. And negative 5 squared is still going to be okay there. So we have no issues with that problem. Number 2, log base 4 of x plus log base 4 of x is equal to 3. So we're going to start off here, log base 4. Oh, we are adding 2 logs, so we're really going to make that x squared is equal to 3. If I want to get rid, so I condensed it first, I wrote it to one side. I can't cancel log base 4 on each side. Instead, I need to get rid of log base 4, and the way I'm going to get rid of that is by raising both sides to a base of 4. That's going to cancel. X squared is equal to 4 cubed is 64. Now we're going to get rid of the square. To get rid of the square, I'm going to square root. X is equal to plus and minus 8. And this gets into some weird land. I know that this is probably a little bit confusing here. This negative 8 is not going to work. The reason negative 8 is not going to work is because it's asking you to take the log base 4 of negative 8. And again, think about what a logarithmic graph looks like. I'm never going to get over here to that negative 8. And so that is not going to apply there. Okay, so only answer here we're going to use is 8. And again, the reason that's happening is because the argument is negative. The argument can never be negative when we're doing these problems. When in doubt, check out Desmos. It'll help you out. All right, let's try another one. Log base 8 of 15 minus log base 8 of x is equal to log base 8 of 3. First thing I got to do is condense it. Yeah, that says log base 8, 15 minus x. So we're going to go 15 divided by x. Now I can cancel the log base 8s because I've got the same thing on both sides. 15 over x is equal to 3. I hate fractions, so to get rid of this fraction, I'm going to multiply both sides by x. 15 is equal to 3x. Divide by 3, divide by 3. X equals 5. Boom, we're rolling. Let's keep going. Log base 7 of x minus log base 7 of 2 is equal to 2. Condense it. We got more than one log base. It's minus, so it's really divided. Boom, there's our setup. We got log base 7 on one side. I don't want it. How do I get rid of it? 7 to a power. 7 and log base 7 are going to cancel. Over here I got 7 squared, so 7 squared is going to be 49. I want to get rid of the 2. So to get rid of a fraction of 2, I'm going to multiply by 2. X is equal to 49 times 2. Or in other words, 98. Keep going. We're doing great. Log base 3 of 2. 2 log base 3 of x. Log base 3. 2 plus that, so it's really 2 times x squared, because that 2 is in front, is equal to the log base 3 of 4 times 8 is 32. I got log base 3's on both sides, so those things could cancel. I get 2x squared is 32. Divide by 2, divide by 2. X squared is 16. How do I get rid of the square? I take the square root. I take the square root. X is going to be equal to plus or minus 4. But again, I don't want that argument to be negative, so it's just going to be positive 4. All right, kind of going back to this one, probably the same, or definitely the same rule should apply. I screwed this one up here. This should just be a positive 5, because if I didn't, I would have log base 2 of negative 5, because then we would multiply it by 2, and that's not going to be possible. So it mattered that that exponent was written in the front instead of behind. That's a little strange. Again, I'm not too worried about it. More than likely, if you could plug in a negative and make a negative, it's not going to be my answer. Last one, log base 3 of 36 minus 2 log base 3 of x is equal to 2. So again, we've got this 2 in front. Be on the lookout for negative logs. Log base 3. 36, we're condensing. It's minus, so we're dividing by. That 2 is going to become my exponent. Is all equal to 2. I want to get rid of log base 3. Raise both sides to a base of 3. That's going to cancel. 36 over x squared. 3 squared is going to get me 9. I don't like fractions, so how do I get rid of x squared? I'm going to multiply both sides by x squared. That's going to cancel. I don't like the 9, so to get rid of the 9, I'm going to divide by 9. X squared equals 36 divided by 9 is plus or minus 4. But again, if I plugged in a negative 4 here, I would have a negative argument, and I do not want that to happen. So my answer is just going to be x is equal to positive 4. Hope that makes sense. It's a little strange. If you need more practice, Khan Academy is a great place to go to get some more practice with these things, and I've got that linked in the assignment. The main idea here is to get rid of logs. You use the same, or you use the raise it to a base. And then if we do have log written more than once, we need to condense first. Hope it makes sense. If not, ask some questions. I would love to help you. Thanks, guys.